Okay, thank you all. I will get started here on today's presentation. Monthly basic training generally falls around product types. Probably keep with that for the rest of the, foreseeable future. Today I'm going to do steam generation 101. In years past, it had been known as, boilers, but with the acquisition or with Spirax acquisition of us and the integration going on, it is important to designate it as steam generation. As a note to all, you're welcome to ask questions anytime as I go through this. Of course, in the end, we will obviously open it up for questions. We can go back and review anything. I would like to give a shout out to Thomas Kibido, Dean Strouser, and Brent Lee for providing some of the content in this presentation. They were available to go. Many of you may know we have a Spirax training facility, and there is a boiler now operational there, and we've got some video to share and some other bits and pieces along the way that will help give a better picture and hopefully make steam generators easier to not only size, quote, and offer your customer, but a better understanding for yourself as well. So let's get started. Now, I did this a few years ago, and this is always a good rule of thumb. All of us here, we sell electric heaters and, most commonly kW, right? We think of everything in kW, thermal input, but it's important to remember, kW is just a, conversion of just a different way of saying BTUs, thermal input into a process. Now, when selling steam or sizing steam or talking to steam folks in general, it's important to know their language, kind of know that market. And so I always think of it as 1 to 10, 3 to 1. Boiler horsepower. That's what a lot of people know when you talk about boilers or steam generators. What's your boiler horsepower? And, the actual conversion is 1 boiler horsepower equals 9.8 kilowatts. But honestly, when you're sizing things and safety factors and all that, you always think 1 to 10. Oh, I need 10 boiler horsepower, great, you need 100 kW. That's pretty simple, pretty easy to go, and it'll also make sense at the end when I show you how to price and size and select these. 3 to 1, you think of the actual steam you're supplying to the process. So 3 pounds of steam roughly equals 1 kilowatt in design. Now, of course, pressure has a lot to do with things. Temperature, as your pressure is higher, your steam saturation and your steam enthalpy is higher. So the heat, we'll say the potential energy of the steam itself is higher. And I'll show you those graphs here in the end. But 1 to 10, 3 to 1 is what I often remember when I'm talking boiler or somebody calls me with a steam application, because quite frankly, off the top of my head and all the years that I've been doing this, I think kW. I would assume most of us on the call do as well. But it's that simple. So we're going to start by doing just a quick walkthrough of the basic components of a boiler, and you'll hopefully, if you know already, or you will at the end of this, how simple these things really are. You got the chamber, you got the heating elements, obviously the heating source, we're electric heating elements. You got to maintain volume in the vessel, so you're creating steam, but you have to maintain a certain level of water in the unit itself. There's water cutoffs, controls, pump controls to keep water in the system and to return condensate. Pressure controls, because quite frankly, we don't want to overpressure anything. There's safety relief valves to help with that. And then the gauges and sight glasses. And that's just obviously a snippet of that. We're going to go through these in detail, but it's important. A lot of these components are now available to us, and understanding them more through some of the other companies that we're now partnered with. So I'll get started. Chamber, really simple and basic. We do our circulation heaters and other process systems and stuff like that. You start with a chamber. This is essentially where the vaporization occurs. We're all familiar with ASME. We are a full ASME shop. And then we've got our standard designs, but then we have our custom designs. From there, it's how the elements mount in. I would hope you all are familiar with, obviously ANSI flange connections. Our standard catalog boilers, however, use a plate flange that bolts on, but it's important to remember that the whole vessel is ASME designed and certified and tested. Speaking of testing, here's some photos of both of our manufacturing facilities for steam boilers, steam generators, apologize. Again, full ASME shop, PED, pressure, regulatory group in Europe. And on the left, this will be a photo of our upcoming and new, and congratulations, we finally sold our first large medium voltage steam boiler, and you kind of see that's called a kettle design, and that just gives you an idea of the customization of what is available to provide steam, where you see the standard designs on the right, which are the vertical vessels with the bolt-on elements and basically our catalog item. The heating source, I would hope everyone on the call, I would trust you all know what the heating elements are at this point. The traditional standard over the years used to be copper because it is most commonly a water application. These aren't talking vaporizers, we're talking steam generators. And then we have ink alloy and stainless available. Honestly, ink alloy is the most common, most recommended, I would say, due to corrosion over time. Copper is still fine. Stainless you would use if you need a clean steam application, and we're talking humidification, sterilization, those type of applications. And basically our CSSB is our CES, the two versions of basically the same thing, only one in stainless. Going from there, I mentioned low water cutoff or controlling the water in the vessel. So if you create steam and you start producing steam, sending steam to the process, you've got to fill the vessel, and then that has to be maintained as level control. We do this with our tank heaters, the same thing. We strongly recommend level control. Well, quite frankly, there it is. Standard on every unit. You can't actually buy a unit without it. And then you got pump control. And why do you need pump control? Well, a couple of reasons. One, you have to fill the vessel. You also have to you have to have a higher pressure filling the vessel than is coming out of the vessel, where quite frankly the water's not going into the vessel. So there's some control involved in that, and there's also some options to bump up the pressure or decrease the pressure to match either with a city feed or however they're feeding our steam generator from there. And then and this is the one that gets misunderstood a lot of times with control, because we're so used to our other process systems where we're controlled by temperature on everything. Now, temperature is a part of this, but these are steam generators. The goal is to have steam. The goal is to have steam at a certain temperature, at a certain pressure to match the process that the customer is requesting. Well, our control is done by steam control, basically. You can you see the picture there in the bottom left, and I'm going to show you a video here in a second of you set the output pressure that you require. The unit itself kind of operates self-contained, building up to that pressure, and is basically working to maintain that pressure depending on the steam demand that by the process or the customer in general. And it continues to try to maintain the pressure that's on the device. Now, something else you'll notice, and we'll talk about in a second in the video, there's two controls there, and a lot of times people see that and they're like, wait, well, what's going on? I'll show you the power distribution in our larger units. It's just basically, think of it almost like a stepper. You got a bank of heaters running off of one. You've got a secondary bank of heaters running off of a second one for a larger capacity. It's not really any different than that. You can even offset them if you like for various reasons, but we don't need to get into that level of detail. We can talk about it later if you want. And then safety relief valve, right? That's common. If something goes wrong, the steam's not able to get out of the vessel, control is out of whack, you have to have a safety relief valve on the unit, and that comes standard, and you see how that's done right there. Pretty common. So let's see if we can seamlessly do this. We will start with, I skipped over the condensate tank. I apologize for that. This is essentially the condensate tank. This is really nice in the Spirax facility. They illustrated, we'll say, the condensate return in blue. You'll see later the steam generation in red. This would be a condensate system, and we're kind of illustrating at the bottom is a pump. Now that could feed back to the boiler as a condensate return, or the condensate vessel itself is required no matter what, because quite frankly you can't run steam just down into your pipes and municipality at that temperature of just condensing, right? So we're talking 200 plus. It needs to condense, cool down, and then you can send it down the drain. 1 second. The one I thought I had was right here, where you have the pressure relief valve that I was just talking about. You see it there at the top. Dean's pointing to it nicely. And again, that's only there for safety relief, right? That should never open up unless there's a problem with the vessel, but it's there as a secondary safety precaution. But as we walk around, you're talking about that, we're going to move to the actual controls, and I'll slide up a little bit faster. Now we're to that two control system that we talked about. Now, Dean did a good job illustrating this. It doesn't translate into a presentation mode in Teams, but I will do these videos and have them posted. But that's essentially the control. You see it on the left with the gauge. Now, literally, the adjustment on the top that he's putting his finger on right now is done with a screwdriver. You literally turn the gauge, and this is where you change the pressure, the outlet pressure of the steam you want. So the customer will have a requirement. They'll say, I need, 40 psi steam, 70 psi steam, whatever that is. Now, that's where you would set that gauge to that type of the pressure of steam the customer wants. The volume of steam is a different story. Volume of steam is going to be based on the amount of thermal input you're putting into the vessel, and that's where you size it for, quote, pounds per hour of steam, back to that 3-to-1 scenario. And then you can even further adjust it and calibrate as needed. And then from there, you see an actual visual gauge on the right to know what pressure you're running at when it's building up the temperature, pointing to that there. And then there's actually even a shutoff, an over temperature gauge over there, which all comes standard with every unit. It's just important. Sometimes when people see, we're used to process and over temp, right? Well, if, in a boiler scenario, they see, all of a sudden you see 3 boxes or whatever, and they're like, well, what went wrong? It's just controlling more banks of elements. That's all that's doing. So, skipping back to the presentation and going through the pieces and parts, let's talk control. I mentioned how the control of the vessel and the pressure is done. How is the power control done? And honestly, it couldn't be any simpler. Now you can get SCR versions and stuff like that. Our standard ones are just contactors, and you're literally switching on a bank of elements. And again, almost like a stepper, right? Does it need to be full on? It'll start to moderate between how many circuits need to be on, all attempting to maintain the pressure in the vessel to supply the steam that is required by the process. And you can see they basically just look like distribution panels, right? And at the same time, you've got all the the level gauges and sensors and stuff that become part of the full integral design. Now you can get elaborate with control, no problem, but you really don't need to for most cases. So seamless as possible. Skipping to that, as I was explaining, you kind of pointing out, so there's your 3-phase power coming in. That's pretty simple, right? And then from there, this breaks off into the banks, which is basically the heating elements. You can see down here in the bottom, that square flange I talked about that's bolted on. And then these, so there's your power distribution, your 480N. And then it's coming over here, your line fusing is right here. There's your contactor. It's that simple. Your signal comes from your pressure is calling for temperature. It closes the contactor. It starts powering the system. It's almost like it's basically just power distribution at that point. That goes straight to the elements. There's your power to the vessel, and there's your closed loop on how that all works. Hopefully that's simple and basic for everyone. Great. Moving on. So I talked a little bit about condensate and the video that came up early. You've got 2 things with a condensate return. One, you could do a blowdown separator. So you're taking whatever process it is and you're condensing the water as a blowdown. And that's more of an operational thing, meaning the question we commonly get when you sell these, how often do I blow down? Well, quite frankly, sorry, got upturned. It all depends on water quality, process, how many times you're doing it. I mean, I would hope if they're turning it off at night, they would blow it down every night. And basically all you're doing, that's a industry term for saying you're basically, draining the system. And when you do so, it allows for build up and things to be wiped away, and it's good maintenance of the unit. At the same time, if you want to get a condensate return, it's essentially the same vessel but with the pump on the bottom to send that condensate back. Why would you want to do that? Well, you think of the heat it takes for, we'll say city water. I don't know if you're either in Texas or Canada, your city water is going to be a fairly chill temperature, not it's not close to boiling at that point. So you've got the time and the heat that you have to put into that water to raise it to the temperature of vaporization, basically. And then, of course, the heat of vaporization to vaporize it. You help eliminate that lag at the lower temperature of raising that incoming water. So if you're able to collect the condensate and send it back to the vessel, or send it back to the vaporizer, steam generator, you conserve energy. It's a conservation of energy thing, and depending on the layout and how your design is, it's a good practice. Another option I mentioned before, you want to maintain a temperature higher than your outlet temperature of your boiler coming into the boiler, or the feed water, quite frankly, won't feed in, and you can't maintain that level in the vessel. Well, we have an option of a low pressure water feed or a high pressure water feed. And they are as simple as that. The low pressure water feed basically takes the pressure down. The high pressure water feed, and you can see by the picture, it's pump. It increases the pressure, fills vessel. It becomes a case by case basis of what the situation, the setup, and what the customer or the client has. But it's really that simple of, okay, what's your incoming pressure? What's your feed water pressure? What's your city pressure? What pressure do you need at your process? You got exchangers, you're running steam trays, whatever it is, there'll be a rating on that. You match the two, you decide whether you need one or not. So with that said, this is where the condensate video, which I already showed, would be to illustrate how that comes down. We already showed that, so you know what that is. It really is that simple. It's basically a vessel and collects the condensate. So let's jump back and move a little further. So I mentioned testing. Be ashamed not to show you. This is the facility in Mexico. You can see them all set up together. They're tested, ASME regulation, stamp plated, all that stuff, high pot, all your general quality that you would imagine comes out of the process of making these. And I'm sorry, I keep skipping back and forth. So that's kind of a breakdown of how basic the operation of these are. What does Chromalox offer? What do we have? Well, quite frankly, we got a lot of old literature to look at, that's for sure. And again, thank you to the guys that went down to the Spirix facility, and we got some updated photos. But I'm going to walk through this really quick, kind of give you an idea of what goes where, and then we'll move to sizing, design, and some more part of the presentation of how to apply your steam. So we got a CMB, which is, we used to call it the OEM item. This is for very small applications, almost like a booster steam heater. Not a lot of bells and whistles. It's even got a dial right there you can see on the side. Same components, just a very small scale, output up to 15 kW. That's not very much, but this is for an application where you just don't need a lot of heat, but you need some. It's a good product. But you step it a little further, you start with our kind of standard designs. You got the CAS, which goes up to 20 kW. Obviously smaller chamber, smaller size. Pressure's up to 90 psig. Now that's the rating on it. Now, are you truly going to get 90 psi out of this unit? No, you're going to get steam capacity of up to about 60 pounds per hour, and that's all based on the consumption of the steam, right? How much they're calling for steam. Moving on, you'll have the CES, which is pretty much the most common unit we sell, and it's 6 to 180 kW. That's the standard vessel size. Pressure's up to rated 135 psi, but in reality we're running at 100, 110 max. But here's the good thing. This is small, compact, all the pieces and parts. It's actually the one in the photo or in the video. There are ways that you can put these together and make them modular, and I'll show you a little illustration about that in a minute. And then we have the CSSB, which is essentially the CES, but in the stainless steel version for those humidification and sterilization applications that are out there. Maybe not something you generally look for, but they are out there, and there's a small amount of competitors in this market. And then you can take the pressure up a little higher in our CHPAS. That's just basically more robust, higher pressure steam if that's needed. Honestly, if you're going to get into this kind of realm, you're more talking, this is, even though the catalog, it's a beefier CES version, but you're probably going to go with one of our custom offerings after that, which would lead us to the CHS. Now, CHS, the actually used to stand for Chromalox horizontal steam generator, but and you see one here at the bottom, but they use the designation for any of the specialty designs that we do. And the KW rating is not really, it's relative, meaning we could offer larger, but in reality, you'll just start adding more boilers at that point because it becomes more practical than some big beast. Good thing is they're electric heaters, which makes the footprint much, much smaller. And a lot of people don't realize, I know they've seen that picture on the top left a whole lot. That was designed to be portable. You can see how they have it bolted in the eyelets here and the corners and stuff like that. And that was to be designed to move around their facility. So you think of just the sheer size of that, and the fact that it's portable as electric can be a real selling point. And then hopefully you're all familiar with our Direct Connect offering. Like I said, congratulations. I know we've sold our first medium voltage boiler unit. That's in production now. We've got photos of some of the other designs that go with that. But even though the scale says up to about 11 megawatts, it doesn't mean they couldn't go higher. It doesn't make sense. This is when if you've seen photos of boiler houses, they put multiple boilers together. That's no different in electric boilers. So you're already a quarter of the footprint of a gas-fired system. The pieces and parts are no different, except that we're more compact and easier to, quite frankly, maintain. And also, you literally can stack them together and make any of these modular if you'd like. Now, traditionally, you can see the scale on the bottom left, what we used to be in the business of what our standard product was. We really don't have a limitation anymore to what we offer our customer. So I would focus it more on what is your supply needs, steam and pressure. Obviously, you've all seen this with, we increase our capabilities with the medium voltage, but it's also to illustrate that your consumption is less, meaning your amps are lower, your install is easier. And it really is a great product to offer your customer when you're talking these larger applications. Some of you may or may not realize that we have standard designs already available in sizing. And quite frankly, if you get into an application that's higher than anything on just the standard offering design, again, this is where they become modular. You can pipe multiple ones, not in series, in parallel. They're all providing steam. You manifold them together. That's how that's how it's done in any facility and how you put that together. So you got standard products, the CES, the CSSB, and all that stuff, and then you got expanded products, and basically just different configurations on how we apply the heat and generate steam. It shouldn't be any more difficult than that. So, just as an example, some of the things I mentioned along the way. This is a good example on the left. A little shout out to Nate Hill on that one. But it gives you a nice illustration of this is a gas-fired system. And all the pieces and parts and maintenance, and it, there's a burner there. There's a lot of things that it's not to say that you don't have to do maintenance on our unit, but if you kind of get the comparison, just a straight comparison of the before and after, it's more compact. You don't need, you don't need exhaust, emissions, all the stuff we talk about on the right for the Direct Connect stuff. But that's kind of the impact. Literally had to build a stand for it just to sit it there on the floor. That's the impact we're talking when you're selling steam to other people, when you're offering them the electric option. And then you take it a step further to the Direct Connect stuff. This is a 2.5 megawatt unit. Now that isn't a vaporizer in the picture, but it does give you an idea of the package of how compact it gets. You look at the boiler house above it. It's still a good illustration. If you can see on the top, they're piped together. They're literally they're literally manifolded together, and it's no different than what you can do with our stuff. I'm going to apologize for a second. Somebody's trying to get in. There we go. All set. I assume everybody's still with me?
Yep.
Okay, thank you. No questions so far? Okay. Well, now I got some other things to share with you that you might find really interesting. So I keep going back to how simple these are to quote and offer and present to a customer. You can go the traditional route of getting E-quotes going through the system. That's fine. That's why the system's there. But when you go to do it, you may notice there's really not a lot to the request. It's, asking you a quantity of boiler, flow you need, operation, voltage. And then the agency approvals. Well, guess what? That's not much because there isn't much to it. It's pressure, output, and that's it. So what I kind of feel like with boilers, and I've always felt like this, is you think pick and ship, they kind of already are pick and ship. They may not, they may be in stock, they may not be in stock, so we can argue the ship part all day. But as far as picking them goes, it's not that difficult. You've got an output, you match the output. If you need more output, you can now start putting more units together or go with a larger unit. Now, we have price guides for that. The price guides are extremely basic because, quite frankly, there's only a few options that I discussed already. But let me throw something at everyone here that I know we're actually even working on internally, and we'll have an offering for this soon. A lot of times we get when you go to the larger boilers, our prices are so high, our design, it's too much. Well, back to these basic units, these CHSs, even if you just compare the standard prices on these things, they're 30, some cases 50% less costly if you go with a modular design. So you can go 2, 3 CHSs that fit right next to each other, quite frankly, in a smaller footprint, and just manifold them together. The good news is now you have redundancy. You can take some out of service. Spirax alone makes a manifold that goes together, and you can rate them out. Again, each unit acts as it's self-contained. It's trying to maintain a pressure that you set it at, and then the volumes based on the output of the unit. So how big is the unit? So that it's always constantly trying to maintain that pressure. So if you're calling for steam, it's trying to maintain that supply. If you're not calling for steam, it's trying to get to that pressure itself, and then it's done. It shuts itself off for a while until it gets to that point. So if you see how that works, if you manifold these in parallel, you can put 2, 3, 4 in a row and match up to the customer's need. I guess the point to me bringing this up is don't automatically jump to the big boilers. We love to sell them all day, don't get me wrong, but delivery, price, and a better fit, we can offer something that is just standard catalog item to match what a customer needs and do the same thing, and sometimes do it better. And I don't think we capture that enough. It's certainly something to check out and consider going forward. Again, operation, this is our standard layout model. I mentioned before, our literature is definitely seen some years, right? But things I mentioned, incoming water pressure, that's all you got to check. It's in a weird way, it's kind of common sense. You got a temperature going out, you got a pressure going out. Well, you got to have, higher pressure coming in. That's easy to check. Your pressure settings. That's it. I showed you those in the picture. The demand, how much volume do you need? And then, obviously the condensate return. You talk steam traps, and that's where we're going to go into next with some Spirax Starco stuff I'm going to show you. The other questions you're going to get with troubleshooting, it's a short list. If something's leaking, that's a no-brainer, right? You saw the fuses before in the video. Element failure is an obvious, right? You can go in and check it with a multimeter. Steam quality, and we'll talk about how to calculate steam quality in a second. But steam quality's got a lot to do with the process after the boiler. Another one you get sometimes would be water quality. Everybody always asks, what's the water quality? Well, quite frankly, we'd like to have decent water quality anytime, which is where you get into the blowdown maintenance of the unit. Some people put a softener or a conditioner prior to the boiler, and what we're worried about now is either scaling or corrosion. Those are kind of the two biggest factors. If you're dealing with gas-fired units, you'll start to get into TDS, total dissolved solids. It's not necessarily a factor for our electrical version. The electrical it's going to transmit to the fluid no matter what, and it doesn't necessarily have an effect. So moving on to Spirax Sarco, you can kind of see what would be essentially their process map, and these are all pieces and parts that they provide. So you see the 7 product segments that they initially have: boiler control systems, flow meters, yada yada yada. You've got the customer need here. Well, we make steam generator. So we actually fit into this model really good. And I've had experience recently, and I'm happy to help anyone on the call, where we go and we sell a boiler and the customer's like, well, what do I need to make the process work? The boiler's fine. It's all the layout and pieces and parts after that that become the real concern. So they have things, this would be their, you talk about steam quality. This unit here, it's essentially a weir or a baffling system where the steam comes in and knocks out the droplets. We do something similar where we have our booster heaters, an inline heater, same scenario. But all you're doing is just knocking out, and those droplets that they talk about in the instruction manual, it's condensate. We're all talking condensate. Steam became water, we get it out. You know, the first product Spirax had is the steam trap. And it's basically this little contraption here that's based on pressure that captures that steam and just basically separates it out and gives a place for that to either be drained from the system to keep the steam in good quality, or return it back to the steam generator to, you know, re-inject it as steam. That's their standard product. Comes out. And then you got the valving. However you lay this out along the way, and there's a couple different ways to valve and pump and do all that stuff. And actually, there's the example in the middle of where I sold one of our steam generators, and the guy's like, well, what do I do? I'm like, well, let's get some valving in here. You've got to control this thing. And there's reasons to use a gate valve versus a ball valve, and then you got your actuators. But all of this stuff is all products that it's standard products that meet the entire steam system. We sell a steam generator, but it's also important to know a good installation involves all of these, and you've got to properly drop out your condensate and keep the system in check for good running. Better than yet, let's have the Spirax people talk to you about it. Thankfully, again, Thomas and Dean and Brent had gone down and done this video, and hopefully it plays all right. There's our boiler there. You can see the hot steam lines at the top. They got them nice illustrated in red. There's that steam trap right there. You can see how it's built. It separates the steam. The condensate comes out the bottom. Pretty straightforward. There's the pillar going over. He's putting his hand right here. This would be this knocks out the particulates. This is their clean steam unit where it separates out any other particulates in the steam, drops them out. So it's not condensate yet. It's more of your steam quality at that point, and it improves your steam quality. Again, all feeding into the same vessel and the same design. If you skip forward, and again, I will process these videos and have them available to everybody. It doesn't work on the presentation side. There's another one if you want to talk sanitary conditions. Again, all moving along and illustrating the different ancillary products that go along with steam generation, a good install. There's, you know, pressure gauges to maintain pressure where we're at. You move down a little further. Now you may notice that every place he has an elbow, you're going to see this little drop place here for drain, for condensate. That's on pretty much anything that they're illustrating. And again, this is their lab in Houston, which is laid out really nice. And then you got, you know, your vessel there. You got flow meters. You got measurement there. Again, every place there's a drop for your condensate. You're worried about your valves, you valving in and out your different things. And so, you know, you move along to different processes and your different, you know, valves and design that you would have providing the steam to. Basically, there's steam chain and they've got good breakaways and things. It's just nice to be a part of it. Now, I'll show the full video at the end. There's an exchanger in the middle, which you'll see right there. You know, how the process is done, where you want your check valves, and essentially building out a whole system to illustrate all the other ancillary products that go with steam generation. So, and I'll show the full video at the end. Moving back, so that's kind of what integrates all the Spirax stuff, right, with what we're doing. So you got steam generation. So now I'm going to talk a little bit about steam superheating and how simple that is. But there's a couple caveats to it can be a little bit different than what you may be used to in a traditional batch heating, tank heating, or process heating application. This is specific to steam and steam superheating. Now, Spirax does have some units, they call them, exchanger packages and stuff like that. And that's basically conservation of energy. We would be booster heating. And what that all revolves around is enthalpy. You can see it in our literature. It's the heat value of the steam at a certain temperature and pressure. And luckily that statement alone, that's actually a linear thing, meaning temperature and pressure, they call them the steam tables, and you can have them. You can go to Spirax-Sarco. Ironically, I used to use Spirax-Sarco steam tables before we were connected as companies. But steam, it's back to principles of just thermodynamics. Steam has a certain potential. It has a certain energy at a certain temperature and pressure, and it's real easy to do the math based on to superheat it, to put more enthalpy into it, more heat content. And so if you take the steam tables, and they're broken into basically two paths. You've got pressure and temperature. So what's 14 psi? That's your standard atmospheric pressure. So that's normal operating temperature. Guess what? Boiling temperature, 212. Hopefully we all know that. But also you should know the enthalpy at that temperature is the 1150 BTUs. That's the potential of 1 pound of steam. And that if it were to transpose back to, if it would go to its phase change, it can give off that much BTUs to the process, the exchanger, whatever it is. That's where the rating comes from. And just a real quick example without diving into this in too much detail, you'll hear the term a lot of times, I have, a percentage saturated steam. What does that mean? Well, it's the percentage of steam versus the percentage of liquid, quite frankly, and the enthalpy that goes with those. So real quickly in application 1, I talk about having 100% saturated steam. Well, what if we had 80% saturated steam at 40 psi, or that's what the customer gave you? What does that mean to you? Well, simply just go to the chart. We know fully saturated steam is the 1169 that you see there from the chart. If we break it into the liquid and the vapor, well, the vapor is 80% quality. So it's not 100%. So you got to take 80% of that enthalpy. So you take that number, that 933 times 80%. It actually has a content of 746 BTUs per pound. We have a flow rate, so whatever the pounds per whatever is. In this case, I'm using 150 as an example. Now, the liquid, the saturated liquid, you have that number, and they obviously, equal out to the end result if you want saturated steam. So what do you have to do? You have to input that many BTUs to vaporize and get the steam back to 100% quality, back to that 1169, right? So then you take those two numbers, and I realize this number is wrong. I apologize, that should be 1169. Subtract out what you have in percentage steam versus your liquid, and that'll give you the BTUs. Multiply by 150 pounds per hour in my example. You need to input 8.2 kW to get back to 100% steam quality. That's how simple it is. And then it goes a step further if you want to talk pressure and higher temperatures and superheating the steam. So you just take the same chart, we're going to 40 psi, and we're moving it up to 500 degrees. Well, how much enthalpy, how much more input do I need in that steam to do that? And it's a simple subtraction at that point. You take the number you want to get to, right? 1284, which you see right there. This is where I want to be in the chart. I know it was at 1169 from the first page. When I got to 100% quality, that was at 8.2 input. Well, to get the rest of the way up to superheated steam, I need another 115.8 BTUs per pound times the 150 pounds that we are doing per hour. I get 11,000 BTUs. That's another 5 kW. But frankly, you take the 8, the 5, the 13. You're going to throw a safety factor on there. It's going to be 15 kW. A lot of verbiage and hard to watch, I'm sure, as somebody goes through a PowerPoint. But what I wanted to illustrate that again to show you something that a lot of you may not realize is out there. Just go download the Spirax app. It's in the Apple Store. I looked, it's on Android too. And they have the steam table. So that chart, and I'm happy to send you the chart. You can, draw a line and, do it old school if you like, or quite frankly, you can just punch in the number and it tells you how much BTUs are in how much pounds of steam based on temperature. Pretty quick, pretty straightforward and easy. Oh, by the way, it also has, I mentioned before, manifolding units together and flow rate. It also has a pipe sizing tool, and it gives you essentially the recommended pipe size. And that would be the minimum size. It's not to say you couldn't go larger, but a lot of times with flow, pressure, and mass velocity, you may not know, you can only push so much through there, and you talk pressure drop and all that. It has a pipe calculating tool in it as well. And that's about it. I mean, it only does the two things, but it is really handy, and I've used it multiple times and probably forgot to tell everyone about it. So anyway, that's kind of steam generation 101. I have, if you guys want to go through and gals want to go through the Spirax training facility, I just saw it this week. I was going to play that at the end, but I'd like to open it up for questions now, as I'm sure I've, talked quite a bit for everyone. No questions?
Hi, Derek. It's Keith.
Hey, Keith.
Can you hear me?
I can. Keith?
Yeah. Can you measure percent saturated steam, or do you calculate it?
I think there are devices that measure it.
Okay.
That's a great question, Keith. I actually don't know. I have to check that out. It's usually dictated to us, right? We got X quality steam. I think it's measured somehow through probably one of the items Spirax provides.
Yeah, there are flow meters, Derek, that will measure the steam and will what do I want to say? That they know when the steam's saturated or unsaturated, and they can accurately measure it either way.
Okay. Okay. Yeah, and I thought that was the case. So in that scenario, Jim and Keith, you're measuring it at a certain point. So you have a process behind that, and so you got to do one of two things. You've got to either collect the condensate, right? And you've seen the separator that they provide that kind of has that weir that it hits and knocks out the particulates. Or back to what I was showing you with the chart, you need that much input into the steam to take it back to 100%. If it's a problem, true too. I mean, maybe they can live with 80% saturation.
Yeah, they typically don't want to. I mean, that's Spirax Sarco's one of their big advantages is their whole. They eliminate what they call steam stall, so they keep it superheated the whole time.
Right, and exactly. Thank you, Jim. And that's part of I guess the value that they provide. Now they do it through almost mechanical means, where we have a product to offer the booster heaters, where we don't have to take it out of the steam anymore to improve the quality. We can just boost the value of the steam. So you can do it either way. But it's definitely one of those synergy items that fall nicely into the mix of the two companies, right?
Agreed.
So, Derek, would it be a scenario where the customer says, "Well, I'm at 80% Chromalox, calculate me how much kW I need to get to 100," right?
That we can do. Yes.
That's a typical question.
That's easy to do. You take those charts that I did the quick example with, and the volume. They have to tell you the volume, but if they're measuring the percentage, I'm sure they know the volume. And then that's what you apply. Say, hey, look, I know you need, in the case of the example, you need 5 kW to superheat your steam or to vaporize your steam. I guess it was 8, right? It was 8 in the example number 1. And it's that simple. You take the enthalpy you want to be at based on volume, the enthalpy that you're at, times the percentage, if that's the case. They say 80%, you got to apply that. That difference is all you have to. You're basically just making up. That's what you're making up.
Okay, thank you.
Great question. So yeah, I mean, and hopefully with steam generators, two things I wanted to do today. One, I wanted to make it simple enough that, and it is, we should be selling these all over the place. I mean, it really is an easy sell. If somebody, you know, gives you, I got X requirement, great. You go in, you set them up, and in a couple of varieties. You don't have to sell them the big boiler. You can sell them the smaller ones, and they can put them together. Also, there's a lot of synergy, and I think everyone realized that before, but maybe not to this degree, of the pieces and parts that Spirax offers to what we offer. And really is a good fit. And there's no reason not to sell it or to offer both as a value add to your customer. I will show the video for anyone who wants to stick around and check it out. Did want to mention to everyone, we do have a couple more trainings still left in this quarter. I will put out another newsletter, probably another week or two, that has next quarter in it. Customer trainings have been going well. If you haven't offered those to your customers or been involved in that, but you'll start seeing some leads of people who are registering for those. Industrial heat tracing will be on the 24th. And also all this information goes into the training site. I've had several requests in the last 2 or 3 weeks for access to this, and I do want to remind everyone, it's an unpublished site, because it's not like we're offering the information to everybody as much as we're just doing it to anyone on this, you know, involved in Chromalox for training purposes and reference. But there are playlists created for most of these topics to help kind of gear what you're looking for. So if you need to go back and reference something or see something, you know, between, you know, just pick and ship or direct connect or steam generation, you can go find what you need. And of course, always, you know, I'm available, contact me. I'm happy to help and move things along.